Okay, this will be a brief review of graphing exponential and logarithmic functions. Before we look at a specific example, let's just remind ourselves of the basic shape of each of these graphs. So when we talk about an exponential graph, the basic shape will be something like the following. It's kind of the basic shape of an exponential graph. And then for our logarithmic functions, it would look more like this. Again, just kind of throwing on the basic graph. And what we know so far is that these two functions are inverses. And to remind you of that fact graphically, if I were to draw the line y equals x in here, something like that, the exponential curve up above is the mirror image of the logarithmic and vice versa. And that's again because these two types of functions are inverses. So we'll look at a specific example of each. First, let's try f of x equals 2 to the power of x. So this will be our exponential one. And in class we talked about some choices for x. So hopefully you feel pretty comfortable with the following choices of -2, -1, 0, 1, and 2. Kind of our motivation here, we said if you go smaller than that, you're going to have really, really small fractions or decimals. If you go larger than 2, you're going to start getting values that are too large to graph. With a base of 2, you have a little bit of wiggle room, but these are a good 5 values to start with. And then to get the y value, you can either work by hand or use your calculator. I'm going to show how to do it out by hand. We know that we've chosen these 5 values of x, so it's just changing out the power on x. So the first value tells me to find what is 2 to the power of -2. We can say that's the same as 1 over 2 squared. So that's how we make our exponent positive. And then from there we know 2 squared is just 4. So we'll use a value of 1/4. If you prefer, you can use 0.25 as the decimal. And then our next value, if x is equal to -1, 2 to the power of -1 is the same as 1 over 2 to the power of 1 to make that power positive, which of course would just be 1/2. If you prefer, 0.5 as a decimal. This next value is kind of our freebie. Anything to the power of 0 is 1. And then the last two are also not too bad. 2 to the power of 1 would just be 2. So that would be this value here. And then 2 to the power of 2, 2 squared, would give us 4 for the final y value in our table. So I've asked you guys to just use 5 points. That's plenty to get a good idea of what the shape of this graph will look like. So I'm going to take away our side work and then we'll get some graphing going here. We're just going to plot those 5 ordered pairs. We already know the basic shape of the graph that we should be getting. And let's see, maybe I'll just give us some graph paper here. So when we start plotting these points, our first one will be when x is -2, y is 1/4. So just do your best. It's right about there. When x is -1, y is up to 1/2. When x is 0, y is up to 1. When x is 1, y is 2. When x is 2, y is 4. So we've plotted our 5 values. Connecting those points will get that shape we looked at before this example, which we know to be the shape of an exponential function. So just connecting those points, that would be it right there, and that again was just the graph of f of x equals 2 to the power of x. And that's all it takes. So our last one I'd like to look at here will just be an exponential function, and I've made it so that this next function is actually the inverse of the one we just did. We'll find that in just a moment. So we have f of x equaling log base 2 of x, and when we have logarithmic form we feel a little bit stuck. We don't know so much what to do with it. So I'm going to go ahead and convert it to exponential form. To do so, I'm going to start by saying log base 2 of x equals to y. We know f of x and y mean the same thing. And then as we've talked about, the conversion here would look like 2 to the power of y is equal to x. So when we start building this table, I'm going to be referring to 2 to the power of y equals to x rather than f of x equals log base 2 of x. This will be more intuitive to us. The unique thing about graphing logarithms is we're going to choose our y values and find our x values. And that sounds a little bit unique. That's something you probably haven't done up until this point with graphing. But the reason is that logs and exponentials are inverses. So I'm going to choose the same values we had in the previous example for x to be the y values in this example. So I'm just going to pop back real quick to our previous example. And you'll notice that these 5 choices for x are now my choices for y. And I can explain that just by saying that these two functions are inverses. So I could run through the same procedure I did with the previous example to come up with the x values. So 2 to the power of -2 would give me my quarter for x. 2 to the power of -1 would give me 1/2 for x. 2 to the power of 0, anything to the power of 0 is just 1. 2 to the first is 2, and 2 squared is 4. Okay, so again, just to make this point, this is a good connection here. The exponential graph had an xy table that you can see here, and as we move over to the logarithmic graph, which is the inverse, the x and y columns just switched. So anyways, we're going to go ahead and graph this now. We have our table filled in. So again, get some graph paper. And as we start plotting these points, when x is a quarter, y is -2. So somewhere in there. When x is a half, y is -1. When x is 1, y is 0. When x is 2, y is 1. And when x is 4, y is 2. Okay, so we see those points connecting to form that logarithmic shape. So again, that shape we were expecting is what we come up with. And this example here was the graph of f of x equals log base 2 of x. So first we graphed an exponential, then we graphed the inverse in logarithmic form. So hopefully that helps as you work with the graphing from this chapter.